guys, today we are doing the notes for February 22nd. This is discovering quadratics, so we're going to start cracking quadratics. Today we're learning all the vocabulary, so some vocabulary that you've already seen are domain and range, ordered pairs, and the xy plane. We're going to start off by graphing the linear parent function. So we're going to do this on the Inspire. If you're at home, you can also get some of this information by going to desmos.com, desmos.com. They have a wonderful graphing calculator tool on there. You'll be able to get most of the answers off of that. All right, so here we go, new document. I'm going to not save my old one. We're graphing today, so I'm going to add a graph. They want us to graph the linear function, which is f of x is equal to x. I've got an f of x prompt, so all I have to do is hit x, hit enter, and there's f of x equals x. And then they want me to fill out a table, so to get to my table view, I'm going to hit Control T for table. So notice when x is 1, y is 1, these are your x values here, these are the corresponding y values. We're going to use this information to fill in our table. So going back to our notes, when x is -3, y is -3, -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, 3, 3. So here's my point, -3, -3, -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, 3, 3. And there is my graph. And that's our linear parent function. The next one they want us to graph is the quadratic parent function. So we're going to go back to our calculators. I'm in table mode. I want to go back to regular mode. So I'm going to hit Control T to get back to regular mode. I want to graph a new function. So if I hit Tab, that'll again take me to my prompt. And if I hit the up arrow, it'll take me to my original equation. But now instead of f of x equals x, I want f of x is equal to x squared. So I'm going to hit that squared button, hit enter, and look at how that graph changes. Again, I have a table to fill out, so I'm going to hit Control T to get my table, and then I can scroll up to see what my numbers are. So let's go back and fill in our table. So when x is -3, y is 9. When x is -2, I got 4. -1 is 1, 0, 0, 1, 1, 2, 4, 3, 9. If you had your calculator in front of you, that's what it would tell you. We're going to go ahead and graph these guys. So -3 over 3 up 9. Get that? -2, 4 will be around here. -1, 1, 0, 0, 1, 1, 2, 4, 3, 9. So here is our graph. All right, so we're going to look at these two graphs and we're going to look at what's the same and what's different. So some things that they have in common, you notice they both have the same x values here. So my x values, let's put the same stuff here. My x values are the same. Things that are different, my y values are quite different. They both go to positive infinity. As x goes to infinity. That might be a little bit more algebra too, that's okay. Both of these graphs go through the points 0, 0. This table and this table both have them. Can you see the other point that they both go through? They both go through the point 1, 1, so they have those in common. However, for the g of x is equal to x squared, all my y values are positive. And you might say, for this guy, it also has a curve. The other one is straight. So one's curved, one's straight. Those are some similarities and some differences between the two. All right, for number 2, it says, does f of x, the linear parent function, and g of x, the quadratic parent function, appear to have the same domain? So we noticed that when we were looking at our x's, these guys are the same. These guys are the same. When I look at the graphs, keep in mind this guy goes on and out forever, so it's eventually going to get to negative infinity. This guy, again, is going to go up and out forever. It's going to eventually get to positive infinity. So the domain for my linear function is from negative infinity to positive infinity. We would also say all real numbers. So remember on your STAR test, you can have it written two different ways. One is in equality form. That looks like this. The other one is written out with order. All right. If we look at the quadratic current function, it's a little harder to see, but these arrows also mean it's going to go on and on, up and out forever. It will eventually get to negative infinity. It will eventually get to positive infinity. So for the quadratic, it has the same domain, from negative infinity to positive infinity. All right, the number 3 asks, does f of x and g of x have the same range? So range, we're talking about y values, and if you look at this graph here, this guy's going to go to positive infinity, it's going to go down to negative infinity. So again, for the linear function, the range is all real numbers. So from negative infinity to positive infinity, but this time we're talking about y's, not x's, and this is for linear. But for my quadratics, looking back up at this graph, notice my y's this one, they go down to 0 and then they go back up. So I never get any negative y values. So my range is just from 0 up to infinity. So it's got a different range. It goes through 0, so we're going to include 0. And then the high range is positive infinity. All right, look at number 1. Now they want us to graph x squared minus 1. So let's look at our calculator. Where you want to get out of table mode. So Control T to get out of table mode. We're going to hit Tab to go back to our function and scroll up to get to our original one. From here, we want to hit minus 1. Make sure you hit this minus button, not this button down here. The minus button at the top. The little button will say times next to it, and you want the minus button. So we're going to hit enter. And if you notice, our graph is now shifted down below the origin. So I want to make the table. I'm going to go to Control T. I can scroll up and down to get my table. And let's go ahead and start entering it. So 15, 8, 3, 0. So when x is negative 4, we're at 15. And then 8, 3, 0. Then we go down to negative 1, and then we go back up. Notice when you're going back up, you've got the same numbers as on the way down. It's interesting. We'll think about that in just a second. All right, so my first point is negative 4, 15. And then I've got negative 3, 8. And then I've got negative 2, 3. 1, 0, 0, negative 1, sorry, negative 1, 0, 0, negative 1, 1, 0, and then we're back up. 2, 3, 3, 8, and 4, 15. Here we go. Connecting our dots. The name of this guy is a parabola. All these U-shaped graphs are called parabola. All right, so put up on the y-intercept. So recall that a y-intercept is where my graph crosses the x-axis, or sorry, the y-axis. So this guy down here is my y-intercept. And seeing that on the table, this guy here is my y-intercept. It's where x is equal to 0, y is equal to negative 1. That's this point down here. And then it says circle the x-intercepts. X-intercepts are where we cross the x-axis. So we're looking at this point and this point. On the table, it's where y is equal to 0. So we're looking at this point here and this point here. Those are our x and our y-intercepts. All right, then it says look at that table, look at your graph, and see if we can figure out what the domain is. So we've talked about this in the last one. The table looks like the domain is just from -4 to +4. But if you look at the graph, it